Now this tutorial I'm not real sure if anybody will ever actually need, but I thought I'd make it just in case. So we are going to, I got quite a few different colliders that work inside the GPU clock physics. I want to show you how to add them, put them in, whatever. So a sphere one, let me go ahead and remove it. That way I can show you how to put it back on. Remove component. Okay, so most of the ones that are colliders, which is going to be your box collider, your sphere, your capsule, actually, and maybe mesh collider. But mesh collider at this moment making this video is not done. I don't actually have it working all the way. It explodes. So I'm just going to show you the sphere collider for now. You can just right click on it and it should have this, the sphere collider helper. After you click it, it will apply and add on your sphere collider helper. This is the script that my tool actually uses. I usually have it defaulted to green. There is no reason. You can change it to whatever color you want. I think it's this sphere over here. We can change it to white, change it to black, change it to whatever color you want. It's just so if you don't have an actual mesh connected to it, you can still see it. That's the only reason that I have that there. And then this friction, I kind of have a little description of how to use it, but I guess it might be a whole lot better to show you. In fact, I'll show you with the sphere, and then I'll show you with the box collider. Let me make sure that I did this. There we are. It says missing because I did that. Just put it back. There we go. And this will take about a minute to load because I haven't closed this since I started making it. So the way friction works on this one is think of it like either glass, like a cloth running on glass, that would be your 0, or your cloth is like a Velcro, which is going to be 1. You won't really notice the effects quite so much if your cloth, the constraints for the stretch and compressing, if those are really high, you won't really notice it as much. But if your cloth is a little bit stretchy, you'll definitely notice it because it'll stick to things and you're keep on walking, but it's not. And it's kind of funny to watch. But if you if you have your constraint kind of higher on the stretch and compressing, then what it'll look like to you is it almost looks like it's kind of bouncing, like a rubber band. So to say, if you were to take a kind of a sticky rubber band and run it across some glass, it would kind of hop along as it's moving. That's the best way I can describe how your friction works. And then on you have plane collider and then a box collider. They're both a little bit different than what you'd probably expect. The box collider, yeah, they're both a little bit unstable. I mean, they work great, but uh, kind of hard to explain. I'll have to show you as soon as this loads. On a plane collider, if you come at the plane collider from a side, it tells the middle vertices, which is actually touching, to that's hitting the collider. So it's trying to push up while the other ones aren't. And sometimes it can explode your cloth or break it, either or. And so if you're going to use a plane collider, I would say try to make it to where it's not going to touch the edges. If you're going to have a plane collider underneath your actor, like let's say you have a really long cape, then it's going to be best that you have that collider kind of big. The collider size isn't going to matter. It's not going to affect your frame rate. So if you're using it for something uh, like your actor, so the cape doesn't drop through the floor, then make it kind of bigger so your edges, so it won't touch the edges, and you'll be just fine. The plane collider is pretty efficient. But let me show you what it does on a box collider. The box collider is the one that's the most unstable. If you have your initialize at start unchecked, then you need to click on this to make it go ahead and start. So here's the issue with the box colliders. They work fine, but something to be cautious of is the corners. I like this so I can show you. If you're touching this corner, and then it knows that it'll go, well, it looks for what direction is touching the box. So if you're touching it from just this side, then it's going to collide against just this side. But if it's touching this side, then it's going to collide against this side. But now if you're touching two sides at once, it actually has a little bit of a push to it. So it's going to be pushing one direction and the other, both at the same time. And with your friction kind of high and it making that bouncing look, you'll see it ping-ponging your outfit around. I mean, it'll bounce pretty crazy if the higher it is. And I'll show you. Now, if your friction is kind of lower, it doesn't do it quite as bad. Let me see if I can get it just right in there and show you the bouncing that it'll do. Okay, so I think that's about right. Yeah, we're touching quite a few sides that way. So let's go down to the box collider. I think this is it. Yep, that's it. I got a lot of things running, so mine's pretty slow at the moment. I guess friction is kind of high. Oh wait, that's not what I meant. Down the top, could enable debugging so I can adjust it so you can see what we're doing. Box colliders, collision padding. The higher your collision padding is, you'll notice it bouncing. See that? It's pulling in one direction, this is pulling another, and now on this third side, it's pulling in a completely different direction. So the higher we get this, you'll notice it bouncing like that. But turn it down and it doesn't do it nearly as bad. And if it does happen, well, if you're touching one side of it, let me try to get to where we're only touching one side. There we go. We're only touching one side of it. It doesn't do it as bad at all because it's not bouncing between these multiple different directions. It'll bounce off of it as I do it once. Well, it went and jumped into the other direction. It's almost a fun show while just watching it all by yourself. Yeah. See, one vertex or two will jump over here and hit this side, and it's pushing this way, while this is pushing this way. And it causes it to grab the entire mesh and jump one, kind of in a average direction, and it's just going to keep on bouncing back and forth because of that. So this is kind of the bad part about using the box colliders. They're great in certain areas, but this isn't one of them. Now we can come over here to the sphere that we were working on. Here we are. And I'll show the difference with this one. Now the way it works is it doesn't ever actually recognize the actual shape or anything. All it really cares about is how big the radius is and the position of the center. The reason being, let me turn this on up. Reason being is that it just measures radius from the center to tell how far to push that out. That's all there is to it. The sphere is probably the most efficient as far as calculations, and it's the nicest and easiest to mess with. Let's go ahead and go down to sphere colliders, and I'll show you the collision padding for this one. This one doesn't do any kind of bouncing. It's very nice, very easy to work with. Now, whenever you are adjusting this, do take note, it is adjusting all sphere colliders that you have for this outfit. Now, if you have this same sphere on two different clothes, then you can adjust it. This isn't actually affecting this. It's only this part that's actually affecting. It's not really affecting the sphere at all. So this cloth is being told to be this far away from the sphere, while you have another cloth being told a different amount from the sphere. So it could be half distance, and it'll this is per sphere, and voila. Now you can actually go into the negatives, but I have the editor to where it doesn't. I don't think there's any reason in the world to have the negatives. On some things, like the plane collider, if you do have it set to 0 and it actually goes to the 0, then your vertices can actually get stuck and they won't come out. You'll rip your cloth and it'll break the physics. So on the sphere, or on the planes, I actually have those done a little bit differently. On the plane collider, each one of them, they have their own thickness. The reason I did that is because some planes you might want to have more padding than other ones, depending on where the plane is, what you're using it for. So, for example, when you go down to your main component here, and you're going through them all, you'll notice the sphere has one, box collider has one. They all have the collision padding, except for the plane. The plane one does not. It is handled on the actual plane colliders themselves individually. So there you go, there's that. In fact, I guess I could go ahead and show you the difference on the friction. So this is what it looks like with the friction being at a 0.8. See, it's kind of bouncy a little bit as I move. Yeah, see, you can kind of see it bouncing a little bit. Now we're going to go down to the sphere, and we're going to turn down the friction all the way down. And now we're going to mess with this a little bit. Now just slide all nice and smooth. Yeah, no bouncy at all. Much better, right? So it depends on the material of your cloth versus the material of the collision. Like, for example, if you are running across a glass floor, okay, you're going to want that friction all the way down. If you're running through a forest with a bunch of sticks on the ground, you're probably going to want to jump it way on up. But that is everything about your collider components. Each one of them are pretty much the same. The only one that's really different is the plane collider. It has friction, thickness, and scale. The scale, basically, it's even on all directions. I didn't want to sit there and deal with transferring more data back and forth of what is needed. So this scale that's up here does not make any impact on the scale that is over here. You can make it as big or as small as you want. You'll notice it changing sizes as I do that. There you go. And this is something I also need to work on, is it's not exact. It's close, but the bigger you make this, the bigger you'll notice that those edges aren't exact. It's actually inward a little bit more, and I can't really get the math on it exact or any closer. So that's something else that's on my roadmap that I'm going to be fixing. If you have any questions or comments, please go to my Discord, or you comment on this YouTube, and I'll get to you as soon as I can.